This is all about robots. Okay, welcome. It's the 8th of March, 2022. We're Robot Builders Night Virtual, hosted by Dallas Personal Robotics Group. We'll do our usual thing, go around the table. For anyone that's not been online before much, we record these and upload them later. So mute yourself or ask to stop the recording if you'd prefer to have something unrecorded. So a little bit of housekeeping. We had a request here just before the start of the call to for someone wanted to get onto the Personal Robotics Discord chat server. So I created this link and posted it in the chat. So I'll post it again here if there are any newcomers. We're still waiting on someone to step up and volunteer to run. We have a list of monthly meeting ideas. I'm not actively chasing them, but they're there, and anybody's welcome to jump in. And as it turns out, we do have a volunteer. Someone, Jesse, reached out to me this week. He's apparently working on a contest with a nice prize package based around the Oak D Lite, which many of us have. He's privately shared some videos, but he doesn't want to make them public until after the contest. But he's going to give on the 9th of April. He'll give a presentation about putting the Oak D Lite to use in an actual robot that drives itself around.
Cool.
So we have a monthly meeting, and it's awesome.
I've got a question. Why does the invite for the Discord channel only last for a few days? Is it what's the?
To my understanding, it's just how Discord works.
It's a setting.
Oh.
That's a setting. What you can do is when you just do the invite, you can put the invite on there. But then if you go down and say more options and open that, then it allows you to set that Discord for any length of time up to permanent.
Oh, wow.
Yeah.
Well,
and that's up to you what you want to set. But
how about that?
Yeah, I'm guessing that Murray probably doesn't want to leave an open-ended invitation for, that just anybody can latch on to.
Oh, okay. Yeah, I want to respect. He set it up and runs it. I want to respect what he's done. But interesting. Okay. Yeah, I don't have an option to do that, Harold.
Okay, and you may not have that option, but
yeah, he's the main administrator. So okay. Well, cool. Well, again, we have the queue to get started on Roboty Things. Paul, Pat, and Harold. So, Paul, what you got?
So an update on Mobot. Done quite a lot of work over the last few weeks. I think I've got some stuff to show. So if you pin me to your screen, I think that should result in me being full screen. And Carl, I'm going to try OBS Studio here. So cool. I'm getting brave. So the first video is a video of Mobot running an odometry cal. So I made it do like 4-meter runs, several 4-meter runs forwards and then backwards, and average the result to find out the encoder meters per tick. So is this showing?
It's okay, baby.
It's on the left tab. It's a vertical format. Is that what you expect?
Yeah.
Perfect. Nice and smooth. Well done. So it's already mowed your driveway and concreted it. Is that the plan?
Yeah.
Cool.
Okay, so that was just video, and there's no audio there apparently. So I'm gonna work on that.
Hey, you can have it find and scrub oil spots off your driveway.
Yeah, that'd be a good idea. Now, are you guys seeing
your code?
Yes, a terminal, and I'm in the top right corner.
Yep, overlaid across the meeting panel, and
we'll get rid
now
of
moved your way. You got it.
Okay, so a couple of things I want to do here. First, let me turn mobile on because I always follow the safety instructions when operating the mobile. So one of the things I did, took a page out of Chris and implemented dynamic reconfigure. And like Chris showed several weeks ago, you can have Booleans, analog values, and drop downs. And so when the Mobot powers itself off, it drops out of bitch mode, self-test mode or bitch mode, which is what I use to drive it. So I just press this button and it sends a dynamic reconfigure mode back down to the app. And let me just make sure that that is running. That is not running. There we go. Let me just get that fired up. And so I've also got, this is the ROS console. So it's detected a large number of lost logs because the ESP32 was busy running in the background while ROS wasn't connected to it. So all of a sudden it's detected a sequence number drop. But then you get all these messages, and these ones that say RL500 are coming out of the ESP32. So I'm using the Arduino log package to publish logs. I've got 3 instances of the Arduino log package, one for the odometry, one for the RL500 robot interface, and one for the PyLink comms. So using them to publish logs of differing severities up to ROS, where they get displayed and can be recorded. And then if there isn't like one of these severity indicators in a module, then it's coming out of the interface on running on the laptop, running on the Raspberry Pi. So anyway, I'll click RL500 bit mode, which sends a dynamic reconfigure down to the robot, and we get some logs that show that a reconfig message came down with these values, and it sent a bit mode request to the ESP32. So I've got very, very happy with the serial transfer link that you pointed me to, Pat, because I've got a whole bunch of messages that go in each direction doing various things, and set bit mode is one of them. And then a log came out of the RL500 module saying it set it. So now it's in bit mode and ready to drive. Just as while I'm on dynamic reconfig, I also set up a callback, a reconfigure for the log level on the ESP32. So I can send a reconfigure message to the node that handles the serial link to the ESP32. It passes it on as a message of a serial to the ESP32 and applies the corresponding log level to the logger on the ESP32. So I've said to verbose mode, then away it goes. And the odometry is, so the odometry is always pumping out a verbose mode log levels, and it tells you it set the log levels to his odom set to 6. So anyway, that's dynamic reconfigure integrated with logging and controlling the robot. So the next thing I want to show is to win my gold star, hopefully, and that is I built a little program called runner.py that accepts some primitive commands to allow the robot, commanding the robot to move. Movo is move with odometry over some distance. Roto is rotate with odometry, stop, stop, ramps it down to stop. And so if we do where's my recipe? Okay, we'll get that ready to fire. And also, we'll get, so another thing that is valuable about ROS, and I'll demo it as a part of this, is ROS bag record -A to record all topics to a bag file. So we'll fire that off here in just a tick. And meanwhile, I'm going to switch cameras. In fact, I'll fire this off. And it's recording them. Fire this off. Switch the camera. The Logicam. Okay, so that was in the forwards direction, and then this probably won't work too well, but I'm going to try it in the opposite direction with a Movo 1. So that was 1 meter backwards, rotate -90, move 1 meter backwards. Now I'll go move 1 meter forwards, stop, rotate +90 and move 1 meter forwards, which should send it in the opposite path, except I'm learning that this platform is not very precise. So sorry about the camera action.
Oh, good.
Okay. And
Cool.
so that has so now hopefully you can see got lots of logs here, and some of the things that let me stop the bag file. Well, okay, stop recording the bag file. So some of the things that tell me this is not a great robot platform are when it's driving, every second it throws an excessive time in set motors request. This is coming out of the RL500 module on the SP32. It spent 375 milliseconds in that. As a consequence, it blew the frame time by 320 milliseconds because it's trying to make a 50 millisecond frame time. And there's a timestamp on that. And it detected 3 lost drive request messages. So there are serial numbers or sequence numbers on each message, and that's how it detected that it lost 3 of them. And those were the 3 messages that were sent while it was down in the bowels of set drive motors request, waiting for an ACK to the motion command from the robot. So very disappointing. But nevertheless, that's what it is. So now I'm going to, so now let's have a look at what it did. And we'll run, so a really neat program is Plot Juggler. Plot Juggler, I'm going to demo it here. Chris probably knows all about Plot Juggler. Um, and I'm going to turn myself off. So Plot Juggler lets you make new traces, new like graphs for adding traces, and download the bag file that we just recorded on the 3rd of the 8th, 1951. Yep, that sounds about right. And it puts up a window that lets you select which topics you want to make available for plotting from. So I've got these ones. It remembers them across invocations. So it's a really well-built program. It's been built over a period of a number of years. And so these are the topics that I've selected. I could have selected any topics, but sorry if this is small, but linear command vel is the topic that transmits motion commands from the app, from the runner app to the robot. And so the X is the drive command. So here you can see there was a ramp going negative and then it jumped negative. Right? So this was where it backed up first. And then I'm going to put angular Z on this trace. So here's where it backed up and then it stopped and then it rotated in place here and then it backed up again here. Can you guys see what I'm pointing to?
Yeah, your cursor's showing.
Okay. And then here's where it drove, we talked for a little while, then it drove forwards, stopped, and here's the rotate where it was asked to rotate, and then it drove forwards again, the second phase. Now, where it gets to be really useful is looking at what the left percent drive was and the right percent drive. So you can see both of them had an equal negative percent drive when it was backing up, and then one went positive, the other went negative as it rotated, and then they both went negative for the second backup, and then the opposite happened during the opposite phase, during the forward motion. And you can zoom in to get a closer look at, just exactly what this looks like. And this button up here zooms all the way back out. And then finally, as an indication of what odometry said was actually really going on, is the left speed and the right speed. So, and again, if we just look at the backup phase, reasonable expectations here on the backup phase. The one thing that I notice that makes me say this is probably never going to be a great platform is, so you can drag this playback bar along, or you can hit the play button to play it. But the backwards motion command was happening around 5.75 seconds into the bag. Encoders started moving at about pretty much close to that. So that's much better than I've seen previously. Sometimes there seemed to be a lot of lag before it actually started moving. Is the rotate command up in the second graph, and then you see the motor's power being applied, but the encoders show that the robot didn't actually start moving, so power was starting to be applied at 11 seconds, but the motors didn't actually start moving till 13 seconds. So maybe an indication of too slow a ramp on the rotate. anyway, just to demonstrate some of the what you can do with plot juggler.
Cool.
Another thing that is kind of cool is starting up, and this doesn't work 100% at the moment, but starting up RViz, and you can also play back the logs and watch what RViz saw happen. So let me just replay that bag file, and oh, I didn't want that. Okay, so this is, so we were looking at it kind of from this angle. You know, we were sitting up here, and it's down. We're looking at the left-hand side of the robot, and what's happening? We'll play the bag file. First bag play, and then the most recent file, 1951, and so let's see. Ooh, whoa. The real robot is going. Stop!
Where's that safety warning when you need it?
and the reason it's going is because the bag file is playing back the commands that came out of my runner app, and the robot's receiving them. So, let me just stop the app that talks to the ESP32 and restart the ROSBag playback.
So can we take that as a testimony to the durability of the pub sub model?
Well, maybe to the dangers of putting idiots in charge of it and letting them let go when robots are live on the network.
Always a challenge for demo day.
Yeah. So anyway, somewhere around, well, this will get up to about 70 seconds, but if all goes well, we'll see the RBiz model do its backup thing. And so this is like, obviously, we're in a toy environment here, and it's a big robot in a very small space, and this is the first time that it actually didn't bang into my bookcase or something. But this is looking at the RBiz playback is a lot more useful when you've been recording a real mission, and someone told you something went wrong, and you want to go back and have a look and see what actually happened, what the robot actually did. And I would have thought it would have been moving by now. Well, I might bail on that part of the demo because that's not working. So I think that's it.
Did we detect a gold star or two in there?
Yes.
Nicely done.
Thank you.
Paul, I had a question for you.
Yeah.
Since I'm working on a similar platform using a Raspberry Pi to communicate through an Arduino by USB serial, I'm seeing a communication latency between the Raspberry Pi and the Arduino of about 100 milliseconds. So it seems like 2 communication cycles before I have the information echoed back to the Pi. So I'll give it a command, run forward, and I would have expected to see that immediate echo back in the next command. And I'm seeing it like 2 commands later. And I was wondering if you're seeing the same type of thing at all on the info you're sending by USB.
I have not attempted, so I'm not sending it over USB. I'm actually sending it over a real 115K baud serial link out of the Pi into the ESP32's serial port. I have not, it's on my list of things to do to measure the round trip latency, but I've not measured it yet. So I'm sorry I don't have that data.
Okay, so
Can
as
you guys
I
hear me?
send the motion command to go forward at an X velocity and an angular velocity, I'll track when I receive the command in the Arduino and I echo it back in the motor data. Coming back.
I hear you,
Here's my
Chris.
motor position. Here's my motor command.
Okay.
How are you
And I see about
synchronizing?
100 millisecond between the two.
How are you synchronizing the Raspberry Pi clock with the Arduino clock? Pat?
So I am not synchronizing the clock at all on the Arduino. I'm just using an Arduino Uno, which is fairly slow in its
Yeah.
on its own. But I'm using essentially I try to read the serial buffer on the Arduino as much as possible to grab
I see. So
anytime I
you're measuring
receive
the
data.
time delay at the Raspberry Pi end between sending the message and getting one back.
Pardon me, how am I doing that?
No, I'm saying that's how you're measuring the latency, the round trip latency.
That's how I'm measuring it. So
Till it comes back.
yeah, so I log it all into a file on the Raspberry Pi. So at this time, I sent the command out, and a couple of every sequence I'll write my data in, and so I'll see like two logging cycles later, or two.
Yeah. I'll make that measurement, Pat, and post it to the list. I don't know, but I've been wondering, and I'd like to know. So I'll let you know what I find out.
Okay, I'll let you know why I'm questioning it. You know, I've got a video to demonstrate as well. I don't have my robot with me. Like I say, it's a couple hundred miles away, but I have a video to present of my latest attempts.
So I have taken those kind of measurements before, and I don't have the numbers in front of me, but because when I first started using sort of virtual serial over USB, I wanted to sort of understand what's the best case scenario and worst case scenario. And I don't have numbers in front of me, but we're talking sort of single digit milliseconds round trip is what you should be getting. Now, of course, as you start putting other layers on top of it, now there's going to be more than that. But in terms of just, let's say, again, and one of mine is, you know, so I'm doing this right between a Pi and a QT Pi. That's one connection, and I'm doing it between a Pi and an Atmega 32U4, and it's all, again, single digit milliseconds what you should be getting. You send a byte over, and you know, almost like a ping and an echo kind of test, which is what I've done before. You should be seeing single digit milliseconds, and it usually doesn't matter whether you send 1 byte or 32 bytes or 64, because it all happens in some increments of some number anyway on the USB link. So that's what you should be seeing. If you're seeing what you said, like 100 milliseconds, that just there's something really strange going on at some layer way above
I'm
sort of the
communicating
actual
on
communication.
my cycle program. So I cycle through 20 times a second. So every 50 millisecond, I'm cycling through. And so what I'm measuring is, so I've received the data at some point. I've sent it out. I have a timestamp in ROS when I sent out the data. And I have a timestamp when the Raspberry Pi sent me back that same data. And it's like 2 complete program cycles before I get the data back.
I think you've got two cycles of latency built in there, because you've got 50 milliseconds from when you post the worst case, from when you post the message to the Arduino until the Arduino would wake up and receive it in its cycle, and then it turns around, posts it right back, and you've got another 50 milliseconds till PyLink gets around to run its next cycle. You might expect to see on average about that value, but I think you've got 2 cycles built into the round trip.
Yeah, so I would have expected to see it back the next cycle. So send it out, and 50 milliseconds later, when I read the value, I would have expected to see it, and I'm seeing it, like I say, 2 cycles later.
But the cycles aren't synchronized, right?
Yeah, they're not synchronized, so it's just read and write.
Yeah, so you can't say you expect to see it back next cycle, because it might have just read and then it has to wait a whole cycle until it gets the message, and then meanwhile the Raspberry Pi cycles again, and then it sends the message back, and you got to wait for another Raspberry Pi cycle. So it's not, your expectations may not be well founded.
Yeah. So that's
Yeah, I think you're onto
one of the
something
things
there.
I'm looking to get away from that is to go to a real-time OS and be able to just read whenever there's data coming in. Is there's data available, I'll read it right away, and write on my 50 millisecond cycle time, where I would write my data back to the Raspberry Pi. So
But
I
what's
haven't
stopping you
implemented
from doing
yet.
that right now, right? I mean, you're describing what you would do with an RTOS, but I'm not sure the OS is to blame here, right? It's what you're describing, what you're thinking of doing with the RTOS. Why are you not doing that now?
Well, that's I thought I was, but it's becoming more obvious to me that I'm not reading it in the proper time. And what I'm getting is I'm doing it twice on my robot. So I'm reading the motor data back, but I'm also reading my USB. And I know my USB, my ultrasonics are slow, but my infrared sensors on my USB module should be quicker. And I'm seeing a lot of latency in that as well.
I do have one question. I don't know if anyone has any experience, but with this, if we're done with your,
Another quarter second sooner.
Does it know it's 2 to 3 inches off?
Yeah, that's what I was going to say.
Or do you know it?
So
When you look
I
at
know
the,
it's 2 to 3 inches off. I'm in the process of getting everything into the same log, so I can confirm.
so your final position, like I know on my robot, I usually get a little dance at the very end where it'll turn in place. Okay. So instead of being the heading error being 0, it'll actually be, some degree. But it knows that it's off. You know what I'm saying? So when I look at the last reading of the heading, I can see that it's off. And if it's off by half an inch, it's off and shows up in the readings from the log. Otherwise, it actually knows where it is. It just hasn't got there where it wants to be, because at the end there you have a capture circle, and so you're going to stop. You might not necessarily stop exactly where you want. What are you using for your at the end? What distance does it?
So right now, like I say, it's traveling 617 centimeters, and I know
Right.
that that's fairly accurate.
Mhm.
But I just stop and pause right now at the end.
Yeah, but I mean, so how do you know you've got the target?
When I look at my data, so when I physically measure it, the distance with a measuring tape, my robot has achieved where it needs to be. And when I look at the data in my
No, Pat, I meant, how does the robot know to stop?
when it reaches its target radius on its XY coordinates.
Okay, and the target's do you as soon as it hits the radius, or do you do a it's better, bad type thing?
No, it's if it's within the target radius, stop.
Okay, so that means you're always going to be one target radius short. Plus, minus your ignition, a minus your inertia of your robot, and yours is pretty heavy.
Yeah, so with the inertia, I'm pretty much on target.
Okay. Okay, gotcha.
So that's not my big concern right now, and I've got to do the as I was talking last meeting with you guys, the UBM mark to square it up and calibrate the center to center distance on the wheels. I've got to get that going, but I need to find a spot. So
Yeah.
right now, I was looking at is just the position at which I start to turn around the box. And it's, to me, it should have, I'm asking it to go, and I'm trying to remember what my program is. I believe it's 45 centimeters,
Mhm.
which is about 18 inches.
Yeah,
And
that
I'm
look-
not getting there. I'm getting about 6 inches before it'll start to turn.
yeah. So if you look at, do you have logs of your sensor data and your heading? Can you see
I do have some ROS logs on the sensor data and the heading.
do they show it reacting as soon as they get sensor readings?
No, and that's one of the reasons I was asking about the latency in the motors, because I'm seeing a slow reaction time in there.
I don't know. Usually motors are pretty responsive. I mean, you tell them what to do, they'll do it pretty quick. On yours, it's a little heavier, and there might be some lag because of the drivetrain, but wouldn't expect it to be. How fast is it going? How's that?
So I've set it. It's driving at 15 centimeters per second.
All right.
And I've
So
set
you got to react. So if you're reacting at 18 centimeters, then you're about 1 second ahead. You're saying when you're within 1 second of hitting it, you want to turn.
Yeah, so I'm within 1 second or so before hitting it. I want to turn.
Yeah.
And I'm not there right now. Like I said, I'm too close.
Yeah. I wonder if
I'm missing it by luck right now. Instead of it sees it and it steers away, but it's a little too late now.
Could you have you tried increasing the reaction? Otherwise, turn more.
I have tried doing that, and I'll get into a condition where it really overturns.
Okay.
So one of the things I'm working on as well is to speed up my motors. So I've got a larger tooth pulley to put on the motor, not on motor, sorry, on the wheels. So I'm going to double my pulley ratio, and that'll bump up my motor speed a little bit more, and hopefully give me a little more reaction ability as well, because I'm still at the low end of the speed.
Okay.
I think my motors are running at the low end, I think, or at 15 centimeters per second, it's 1,600 RPM at the motor. Which is, on a motor that'll do 10,000 RPM, it tends to be a little on the low side.
Yeah. So what percentage of PWM are you sending to the motor when you're getting that condition? What I'm saying is, Pat, it shouldn't be more than about 70%.
70% of speed? Oh no, I'm so far below that.
70% of PWM.
I'm at right now, because my rate is so low. I'm at like 3.7% of speed, of full speed.
So your PWM is only running 3%.
I'm only at 3% at 15 centimeters per second right now. I'm really slow in my motors.
Wow, that's low.
Yeah,
that's real low. Yeah, I would have thought that your cruising speed, like I say, it should be less than 70%, but it shouldn't be, less than say maybe 30%.
Yeah, I was aiming, I'd like to get it around 50%.
Yeah. Yeah. Oh, I don't know.
I think part of my problem is the huge wheels I'm using, so I've got to lower that belt ratio a little bit.
Mhm.
Pat, I watched the recording and you were from last week. You had some issue. You were saying the way you're starting all your RAWs applications, you had a communications issue. You felt that to solve it, you'd have to go to launch files again, where it gets a bit convoluted. Did you resolve that, or is that still an issue?
No, that is resolved. I went to a launch file. So
Okay.
I created the launch file to launch all my nodes, and I've created in the launch file, I also have some parameters that I'm sending.
Okay.
So I'm
Because I
sending
was going to say that I'm not using launch files. I'm just running my Python application. I guess I'm not seeing the issue that you're seeing, although I'm not 100% sure what issue you're seeing, but I'm certainly not seeing any communication issue, and I stayed away from launch files just to keep it simple.
Yeah, I was launching my Python in a batch file, all my Python routines in a batch file, and it was working good. As soon as I introduced ROS into it, ROS kicks up a complaint about it, and it just basically fails. So I would open a terminal automatically out of the batch file. So LX terminal -E for open a terminal, and then launch my process, and then ampersand at the end, and then launch the next process. So they would open up. When I was using MQTT, I'd open up 6 or 7 terminals automatically, and launch all these programs, and it was working well, or fairly well. That would not work at all with ROS, with Python and ROS. It just absolutely failed. I could launch them manually and it would work, but I can't launch them with LX terminal -E.
Okay, yeah, I'm launching everything manually, so I guess I'm not sure exactly what.
Yeah, so I bit the
LX
bullet.
terminal -E thing that you're doing. I guess I'm not familiar with that, but I guess one thing to always watch out for, when you're launching stuff, is especially if you're trying to put stuff in the background, if it wants a console to talk to, you can run into gotchas there in Linux, right? Sometimes you have to make sure that you redirect the input and the output appropriately so that your Python script can still keep running in the background, and it thinks it's connected to to an input and an output. So depending on the nature of your programming, you try to keep it just running in the background, and then whatever launched it goes away. Boom, all of a sudden it becomes unhappy and it just goes away. So there's ways to do that. It's really maybe more of a Linux thing than a ROS thing to keep applications
ROS is good with the launch files with that,
background.
because ROS will take something that when you shut down your process, it'll go actually through and kill all of the other processes, all the other nodes that are running when you kill your launch file.
So that console disconnection thing going on there, I haven't played ROS 1 much, and I've been doing with ROS 2, and you get a ROS out from the get-go for all this stuff, right?
Yeah.
So is that losing your console or disconnecting your console?
No, this is a Linux terminal console.
Oh, I understand that. I understand that, but there's a debugging channel or debugging topic in ROS 2 that you can always subscribe to that all this noise goes to. And if you do a get logger, in fact, I'm trying to work through that right now, but so I understand that. So there's a logging channel that you can always attach to and always do all the stuff. And then you can subscribe to that channel or echo out that channel as a topic to see what all that mess is. That might help you do some of that stuff too if you look into that avenue. Just thinking. I don't know because I'm such a noob at all this, but I'm learning things. I'm like crazy.
I think what the launch file ends up doing for you, Pat, is it's exactly that, sort of taking care of you know, keeping all the separate apps happily running in the background, thinking they're connected to a console. I think it's just taking care of that for you without you having to sort of think about it much. But then
Yeah. Well,
when
the
you
other
stop
good
the
thing with
launch
that as
file,
well.
everything stops, right?
Yeah, but the other good thing with that is when I'm communicating and writing log messages out of my routines to Ross log, I've got a timestamp out of the computer, and everything is synchronized for timestamp. So that makes it really handy when I'm going through and troubleshooting and looking at the data from all of my nodes. So
Yeah,
I can
okay.
synchronize, and that's what I've been looking at basically is, okay, well, hang on. My ultrasonics saw this at this point of time. How long did it take my motor to react to this signal? How long did it take my arbitrator to say, hey, stop following navigate and start following avoid?
And then when you make a change to your program, you kind of kill the launch, and that stops everything, and you just restart everything.
Yeah. So it kills when I kill the launch file, it'll shut down everything. And if something is hanging, because I find that even though I've got I'm trapping Control C and I'm trapping ROS exceptions, I still have stuff that'll hang once in a while. But launch is good at finding it and killing it.
Okay.
So that's what I've been working on right now, is trying to get my timing a little closer together.
So Pat, I just put in a little test that sends a ping and then measures the time when the pong comes back, and I'm seeing 30 to 60 milliseconds round trip time, and 10 milliseconds of that is built into the polling on the because I'm using callbacks on the ESP32. So as soon as a message, so there's a 10 millisecond polling loop that polls for calls tick on serial transfer, that causes the callback to be taken, which then posts a message to send the pong, and then the pong is polled for sending every 10 milliseconds. So there's actually 20 milliseconds of loop time in the ESP32 built into that 30 to 60 milliseconds. So I'd say the round trip time I'm seeing is, it's round trip 30 to 60, but if I had different processes, one process doing reads and the other process doing writes, which I think is I've considered, then that should be, I would think, in the order of 20 to 40 milliseconds.
Yeah. So what I've done to get my response time on my motors and everything working a little quicker is I'm running my motors on 100 hertz loop. So my PID loop is running at 100 hertz. So, and that's to control the velocity of the motors compared to PID input and error. My communication back to the robot is running at 20 hertz. And I found since I've done that, I'm getting better acceleration, deceleration on my motors, running at 100 hertz. The other thing I do is using a rate that I'll link, using a rate, basically, I'll increment my speed 30% faster every 40 or every 50 millisecond loop. So if I say, hey, run at 15 centimeters per second, well, the first time through the loop, it's going to say, hey, set that at 5. This next time through the loop, it's going to be, hey, run at 10. And the next time through the loop, it's going to be run at 15. So it gives me
is
about
that your
150
slew rate
milliseconds.
limiter?
Pardon me?
Is that effectively how you're limiting your ramp up of speed?
Yeah, that's how I'm limiting my ramp up. Otherwise, if I don't get into belt tensioners on the two pulley belts, they'll start to skip and slip because I can overdrive them. So I found that I can safely work at that speed right now at 30% per loop.
Pat, just curious, at your 100 hertz PID rate, what is your maximum encoder count at full speed?
Well, I'm not running, so I'm running about 103 encoder ticks in 50 milliseconds.
Now the PID controller,
But my PID loop for the PIDs to set the velocity on the motors, I'm using my encoder delta time between ticks to calculate that. So I'm calculating that in micros and converting it to a velocity. And I do that on every encoder tick. So what I do is I recalculate that every encoder tick. So I calculate my delta time between my encoder ticks. And then every 50 milliseconds, I will look to see if I have a change between my 50 millisecond encoder count and my next 50 millisecond encoder count. And if they're both the same, then that's how I set my velocity to 0 on my PID loop. So I found that gives me a little better control over the motor speed than instead of running at 50 milliseconds on my loop.
okay, if I understand what you're saying, the calculation of the speed of the robot, the velocity of the wheel, is happening at a slower rate than the PID controller itself.
No, the calculation of the velocity of the robot is happening every encoder tick.
What was it you described happened every 50 milliseconds?
If my delta encoder time at 50 milliseconds hasn't changed, so my encoder count last 50 milliseconds is the same as this present time, I call that 0 velocity.
I think what David is suggesting is that you may actually be, in some circumstances, running the PID loops faster than the tick rate, because as the speed ramps down to close to 0, your tick rate increases beyond your 50 milliseconds, but you're still running the PID at 10 milliseconds.
Yes.
So you're going to have possibly five PID loops within one encoder tick period. I think that was what David was asking about. I'm not sure where he was going with that question.
Yeah. So if I have five encoder ticks during that period, all I do is I feed back the last time difference between the last two.
No, you might have 5 PID loops between encoder ticks.
Yes. It's quite possible. As I slow down to 0, my delta encoder pulses gets to be larger and larger. Yes.
Yeah. Not sure why that would be a problem, but maybe David wants to explain that.
Let me swallow. Well, I'm not sure I totally grok what you're doing exactly there. In general, a PID loop has 2 inputs, and one of those inputs is the set point, and the other one is the measure coming back from the plant, and those have to run at the same speed. That is, if the PID loop's running at 100 hertz, you have to sample your velocity at 100 hertz.
And that I sample it actually at more than 100 hertz. So when it's time to do my PID loop, I've got the absolute latest value on my encoders.
But you can't if you're traveling slowly enough that you're only getting one encoder tick per 50 milliseconds. Well, let's say it's 49 because you haven't quite declared stop yet. Then you aren't getting updates to your velocity for each new run of the PID loop, because you haven't had a new encoder pulse.
Well, don't forget that my encoder pulses are not happening at 50 milliseconds. They're
They
having
may
my
be
encoder
going
update.
slow.
My delta update, my delta T between encoder ticks. It becomes quite feasible that I get one at 50 milliseconds. So I've only seen one encoder tick in the last 50 milliseconds.
That's only when you're going really, really slowly.
That would be really very slow.
What's typical? You said at maximum speed, you're seeing something like 50 ticks per PID
I'm
cycle?
seeing about
or-
102 or 103 encoder ticks for 50 millisecond time.
And that's at your slow full speed of something like 17 centimeters a second or something like
Yeah,
that.
15 centimeters a second.
Yeah.
But what I'm not tracking is that so the PID loop is sampled at a constant rate, yes,
Yes.
a constant rate every 10 milliseconds. But the encoder ticks are asynchronous to that. So
They on an interrupt?
Yeah, they're on an interrupt.
yeah, well, so that's fine. So what it means to me is that if we just forget the PID loop for the moment, every time you get an encoder tick, then you calculate the period between and call that the velocity, right?
Yes.
Okay. And then what happens if okay, so let's say you get encoder tick, so you have a fresh velocity. At that point, shortly after that, the PID loop happens to get sampled, so it gets a fresh velocity. So let's say you go another 10 milliseconds, the PID loop samples, but there's not been any recent encoder tick. So do you give the last encoder velocity or zero? What do you give for a velocity if there's been no encoder ticks in the last PID loop period?
So if it's the last 10 milliseconds, I
Yeah.
will give it the last value I had.
You'll just carry over the prior.
It'll carry over. So
Okay.
if I reach 50 milliseconds and I don't see that updated, I'll call that a zero. So it'll get smaller and smaller and smaller, and then at some point it'll stall out at a value.
It'll stall out of the value. But
And at
I mean,
50 milliseconds, when I do my loop, my update loop for my input and output values on my robot, my communication, I'll call that, hey, I haven't seen a change. My delta encoder between now and my last time is identical. So zero out my velocity.
so if there's no, okay, so I think I get how the encoder part captures and measures velocity, but then in terms of communicating from the velocity reader to the PID loop, is a value only presented in once it's consumed, is it gone, or once it's recorded, is it there, and until in the PID loop, because you might go 2 or 3 or 4 PID loops with no new encoder ticks and no new change to the velocity.
So if I go 2 or 3, if I go one complete, not a PID loop, but if I go one complete 50 millisecond scan of my program,
Yeah.
and my encoder ticks haven't updated, I call that velocity zero.
Okay.
So I think what's relevant here, Carl, is the rates that Pat mentioned. So he said he's getting 100 ticks per 50 millisecond period. So that means at full speed. So
Yeah.
at full speed, he's getting 0.5 milliseconds per encoder tick. So as he ramps down to 10% of full speed, he's going to get 1 encoder tick per 5 milliseconds. So he should get 2 encoder ticks per PID loop cycle. So things may get sketchy when he gets below a couple of percent of full speed, but at 10% of full speed, it sounds to me like he's going to have a couple of ticks, so he'll have a valid speed.
Yeah. So when I lose those speeds and I have to rely on the 50 millisecond to zero out my velocity, I'm pretty much stopped.
Yeah.
But on the way there, it sounds like at any time that the PID loop samples the value, there's always a valid value. It might not have changed. It might be carried over from before, but it's not like one of these values that's available once, then when it's consumed, then there's nothing else left.
It doesn't go away. It stays.
It stays. Yeah.
It stays until my 50 millisecond loop sees that my present and my last encoder counts are the same. And then it'll say, hey, you haven't changed, so zero it.
So that seems reasonable to me. I mean,
So I did the 100 hertz loop on my motors because I ended up with a gear ratio that is so, like, I'm running my motor at such a low speed. So, you know, to get a PID to work at 3 or 4% of motor speed, you need to do something. And 20 hertz loop wasn't doing it to calculate a PID to keep that motor spinning at a very low speed.
That's when you need it the most.
That's why I increased the calculations and changed the velocity to be able to get something.
I need to think a little bit about the way you're calculating the speed there, and maybe it's not an issue, but my initial thought was that, as Carl was describing, there are loops through the PID controller that the velocity is not updating. It's just going with an old velocity. So the PID controller, because it's got an integral in it, you'll see that it's not fixing what it's trying to fix. And so it'll start to ramp up the integral. And as I say, you really need to have a fresh update for each time through the PID loop. And it may be that what you're describing is that you actually do have a fresh update, except at very low velocities.
For the most part, I believe I do.
What Paul was describing is kind of the rule of thumb I use also, which is that you have full speed and then you have 10% full speed. So you go 60 miles an hour, you go 6 miles an hour, and that's kind of the range of the, and it does sound like when you're at 10% full speed, you still have a couple of ticks for each new PID loop. Generally, it doesn't do any good to calculate a PID value if you don't have an updated value from the plant.
No, I agree with that. Yeah, if my value is going to be the same, it's essentially I might as well be stopped because it won't
you can have the same. You can have the same value over and over again by going at constant slow speed. That's not stopped.
No, that's right. It's not stopped. It's just constant speed.
but if your integrator is 0, then it should be no problem, right? You're not going to have a buildup of error if it's just PD.
Yeah. So the other thing is the only time I'm going to get that very, very low, long delta time between my encoder ticks, I am essentially stopping.
Okay, well, we're not talking about, I'm not talking about stopping. I'm talking about driving really slow.
Yeah.
Say 10% full speed. So ignore the whole stopping out part of the algorithm for a moment. You go through the PID loop and you have four or five times through the PID loop, the plant is giving you back the same value because it hasn't updated. It doesn't have a new value to give you. So it's giving you back the old value. So the first time through the PID loop, the PID controller says, oh, we're going too slow, so ramp up the voltage. And the second time through, it says, well, we haven't changed any, ramp it up some more. And so forth, third and fourth time through. And so that because you're updating, you're differencing the set point with the measured velocity, but the measured velocity is not changing at the same rate that you're polling it.
I think he is getting updates at that speed.
Well, that's why I said
it sounds like he's getting plenty of updates at that speed.
My updates on my velocity are happening much faster than my PID loop. Up until the point where I run out of encoder ticks. So if I have no delta encoder tick between the tick and the last tick, essentially I'm at 0.
I see. So the 50 millisecond window, it only comes into play when you're trying to decide whether or not you're at 0.
Only when I'm at 0. So I say, because I can't measure one tick against nothing. So I say, hey, the last time I measured it, because I do it in an interrupt routine. So the last time I measured it, I had this velocity, really slow. And I get to 50 milliseconds and I say, no, it's not 0.1 or 0.01. It's actually 0.
I don't understand why you can't always calculate the velocity, even a 0 velocity. That's not
If
clear to me.
I put a timer in there, then I could. But if I do it off of the encoder, so when I get an encoder tick, I'll copy my last value encoder and basically create a delta encoder value, and I use that in my routine just before my PID loop.
But you still have to compare it against the time source to get any kind of velocity.
I do that inside my the last microseconds versus the current microseconds on my tick. And I write that as a delta microseconds. And that just gets stored as a value, delta microseconds. Just before I call my PID loop, I go read that value, whatever when the last tick was. And I get a value out of that to feed into the PID loop.
Hey, Dave, you think the, the fact that at extremely slow speeds, your PWM is going to be, less than 10%? And could that influence basically the whole behavior of the platform? It may not be enough to keep a motor rotating, right? Might be not enough energy.
Shouldn't the PID take care of that though?
Even at those very low.
Well, sure, because when it sees the speed is too low, I agree that, down on the low end, the PWM may not be very efficient.
Right.
Okay. Yeah. So I think I misspoke when I said I'm at like a very low. I'm at about 25% of my PWM.
Oh,
I'm
20%.
sending a little more than 25%. I'm sending out the Polulu routine I'm using goes 0 to or minus 400 to plus 400. And I'm sending out about 130 to 160 as I'm going at 15 centimeters per second. So it's in the 30% range.
That might be involved or might not. I think what Ray is describing, if I understood it correctly, is that most of these motors don't start turning, when you get to 1%. You have to kick that value up somewhere. Still, if you wanted the robot to move at 1%, then basically the PID controller will keep ramping it up until it starts to move and then ramping it back down when it moves too fast, and you can move along at 1%. That the PID controller can do that.
Yeah, no, I think I misspoke because I was confusing my 15 centimeters per second and my PID loop output. So my PID loop output is 130 to 160 at 15 centimeters per second. So it's
and that's full speed.
Pardon me?
That's a configured full speed.
That's
So it's self-limited. It's not real full speed. It's just what he's defined as his
real
maximum.
full speed. It can travel much faster than that. I'm at about 35% speed on my, like 35% output on my pulse width modulation.
When you're clamping your full speed, is that before or after you let your PID adjust your speed?
I clamp my PID for max or min output.
So when you're going, quote, full speed, I guess what I'm asking is, are you allowing yourself to still accelerate one side of the robot if you're trying to turn, or is it entirely up to slowing down the opposite side that you want to turn into?
Right now I'm still doing both, so I haven't gone to that as of yet. So that makes a really good point, Kareem, that possibly I am limiting my output when I am making that turn around the obstacle in the hallway, the box.
Yeah.
So if I'm, because my right wheel would need to speed up, and if I'm already at 150, which I've limited my PID loop, 150 plus or minus 150 output.
Yeah, you
It
may be clamping
limiting
half
how
of
much
your
I can
reaction.
turn in that direction.
Yeah, or it could only turn so much or so fast
Yeah.
because it's limited.
Well, that's a fairly easy thing to try when I'm home, is just to open that up to, if I'm running at 150 maximum, I can open up to 300 plus or minus 300 on my PID loop.
Take off the
And-
training wheels. Give that a shot.
And see
Let
if
it
it
rip.
makes a difference. Do I turn earlier? So am I at my turn limit basically on that?
Go for it, man.
Pat, if you're using
Turn that knob up to 11 and just smash the button, dude.
if you're using like like the Ross twist command or the equivalent we've talked about with a velocity and a rotation separately,
Yeah,
then
I am.
what you want to do is you want to limit the velocity but not the rotation. So that has to be a limitation on the input rather than on the output. So you say I want to go 50% full speed and I want to turn with a rotation of 10, then one wheel is going to go 60 and the other is going to go 40. So the outside wheel is actually turning faster than the limit you set. So the limit is just a limit on the velocity, not a limit on the rotation. Although, I mean, obviously, if you overflow 100%, you need to take care of that.
Yeah, and that's where I'm not overflowing 100%, but I think I am overflowing my PID. I think I'm clamping probably, and not allowing my outside wheel to turn faster.
As I say, that sort of is handled automatically if you think about clamping the velocity as being something that happens on the input side rather than the output side.
So clamp the X velocity, but not the angular velocity.
Yeah, and you do that, you're just basically, you're saying I'm not allowing the input to request 100%. The input's only allowed to go to whatever I want my max velocity to be, say 50%. But then when the calculation of the left and right wheel velocities are done, from there on, there's no clipping of the output, except, as I say, if you overflow. I think that's what Kareem was referring to. If you're already going 100%, I'm a little confused why you're not running these tests at 100% if you can go 100%.
Oh, because then all the nice stuff I have in my house won't be nice anymore.
Well, maybe you're.
It's a 30-pound robot and not a 1-pound robot.
But it's expected to at some time go 100%, right? Or at least go fast.
Outdoors,
No.
maybe.
This is going to be staying indoors, and
Oh, is it?
originally I was thinking.
So you don't have a high enough gear reduction.
Well, I'm gonna double my gear reduction. That'll help. That'll bring me closer to, let's say, 60% of speed.
I generally run my robots around at about somewhere between 40 and 70%, depending. That leaves plenty of overhead left over for steering without bumping into the 100%.
Okay, I'm just pulling into GitHub to see what I have my PID loop set in.
But with a good gear reduction, and then with the proper manipulators, you could just use it to move your furniture around. Then that'd make your wife happy.
He's got to work on that torque transfer too, because if his belts are already slipping at this high speed ratio, then.
So what color star do you get if you move your furniture around with your robot?
If you ask us, it's gold, right? I think if you ask your wife, it's another thing. But
I think it'll be a black eye if I ask her.
It's a splintered wood star, I think.
Yeah, so I am clamping my output on my PIDs at plus and minus 150. So I think that is.
I don't think you want to
really
clamp
good
the
line,
output. All you want to do on the output of the PID is prevent it from overflowing 100%. I don't think you want to clamp the output. You want to clamp, as I said, the input.
Okay. So that'll be an easy enough to check. It's just I can't do it long distance. I'm optimistic about this. I think it might help with some of what I'm seeing, where I'm slow turning one way and then I'm slow turning back the other way. That's it for me. I've taken up enough time.
oh, cool. Well, did we detect the robot moving in there? So is that another gold star? Yes. Good way to go, Pat.
You had some
All right.
navigation and avoiding in there.
Yeah. Excellent. Okay, good deal. Okay, so next we have Harold and Kareem, and I know Kareem, you have a short thing you said to show. Harold, did you have a longer one or a shorter one?
It's not. It's kind of short. It's
Okay.
kind of short. I want to. I just want to show off a robot. I came across my thing a bit ago, and pull my thing, my little transition action. Yeah, so make sure it works. So I'll put this in the link. I thought this was a really cool little robot. And it came across, and I'm like, huh, what about them apples? I don't know if the sound will come out. It don't really matter at the moment, but I think you'll get the idea. The thing is, it travels on C. I put the link in the channel, and if I hit it go, in fact, I'll just turn the sound off because
Whether you're new to the world of connected data or a seasoned graph veteran, Neo4j's Graph Databases book will.
Thank you. Okay. Basically, it's moving like one of those Spanish dancers or some other sea creature. And I thought it was pretty darn cool. And
Maybe
I
a
wanted to
manta
show
ray.
off. Or a manta ray. Yep. Works the same way with the ray stuff, right?
Yep.
And I wanted to share this a few weeks ago. It just didn't happen. And it looks like there's a couple different ways. It's got more cyclic and less cyclic node things on where it's going. Oh, look, it's in the snow. It's been a while since I've watched all this. But I thought it was really, really cool, and I kind of wanted to look at that one. That's like up, down and stuff. And full of things. Anyway, I thought that was cool. I wanted to show some off to it. Also, I've been working on some ROS 2 stuff in my stream, and I found I was doing it completely wrong. I was thinking that I need a configuration node, and all the nodes that ask for their configuration and do kind of a spin waiting, because that's one of the things you can't do in ROS 2. I found out is you can tell it to look for a node, and if it's not there, it'll sit there and wait for the node to show up, and then I'm like, okay, cool, we can do that. I talked to a couple of people and read some stuff, and they go like, that's not how ROS 2 is built. So I'm going to be using some dynamic parameters out of YAML, out of the YAML to read them, and I'm currently working on how I get all that thing set up. And had a lot of good time. And I don't know if I'm doing it right or not, but we've got some object-oriented stuff, and now I understand a little bit more about when you folks are talking about you don't send an X, Y, and Z or whatever. You send a velocity in a heading to all this stuff, and then you let it figure out somewhere along the line how to make that velocity and heading work. And so I've got some diagrams that we worked through that bears that out. I thought it was really cool, by the way. And I was like, hey, so I'm actually listening to you people, believe it or not. I know you probably think, yeah, Harold, he's just making noise and that kind of stuff. But no, I'm actually listening to it. Also, while I have all of you on here, I have a few of these. And if you don't want them, I'm going to give them away to somebody. I got 1, 2, 3, 4, 5. I think I got 6 of them. So I'm going to hold them up. These have been sitting in my garage for a very long time. They are an insider dev tour thing that I did a couple of years in a row, and these were extra glasses that I've had just sitting around. I don't want to throw them away. They're brand new. I can only drink out of so many things. So if you want one, send me a note or drop me a line or do me a thing or whatever it is. You give me an address and I'll be happy to send you one. Like I say, I only got 6 of them though. And then on another note, the meetup we've been doing, the Hackster DFW, I don't know what's coming of that. We'll have a talk to the Hackster people tomorrow. And if at the very least though, Ron's got a lot of hardware and we're about to go through that and see if we can't give some of that away. And some of that hardware is old, and sometimes we have a lot of hardware. It doesn't even exist anymore, so I don't know how useful it's going to be. That's about really all I had. The things I'm planning on and going and doing. And by the way, I hate zebra printers. I just hate them. I just don't like them. And that's what I've been messing with for the last few days. I mean, the last few weeks actually. and we're not even close to actually getting where we need to get with those things. But those little printers that sit around that print out name tags, we were printing RFIDs into the tags and having them come out, and trying to get my server guys better information is just killing me at work, because it's fire and forget. You send some data into it. All right, hope it came out. That's all you get. And of course, they have SDKs, and those SDKs do .NET up to 4.7, and they do some C++, and it's all old Windows crap. So anyway, now I'm whining, so I guess I should shut up.
Tell us what you really think, Harold.
Oh, it gets worse, trust me. Worse. Just simply because, if they support Java, so I might have to do Java, and I haven't done Java in forever. I mean, last time I did Java, it was called J#, which was how Microsoft got sued for all that. So that's tell you how long ago that was. And no, but I mean, it's just, at least if you're not going to develop the thing, make it open source, and there's plenty of people out there that'll make it happen, because we want it to happen. Heck, I might even devote some time to it to make it happen. But not happening yet. Anyway, I can whine some more if you want, but tomorrow night, as far as the only really other robotic thing I have, my Mr. Big Head Twitch bot. We'll be working on that tomorrow night, and I'm taking everybody to the very start of that. And last Wednesday night, every Wednesday night, we're working on Mr. Big Head, and it's kind of got AI in it and a little bit of a bot, because you can press a button and it'll speak to you and all that kind of stuff. But we're taking them through getting their stuff set up on their box, because people want to help me. And this tomorrow night, we'll be downloading the complete repository and running the make and see how we do all that kind of stuff. So it should be fun. Yeah.
Cool.
Yeah, that's about all I got. Nothing too crazy or exciting or new or anything. Yeah, that's about it.
Sounds good, though. I mean, keeping busy.
Yeah, no doubt about that.
All right. I think, thanks. I think we have Kareem next. And anyone want to go after Kareem? Oh, my goodness. Okay. Well, Kareem, have at it.
Might be a short evening.
Well, I have something, but it's not robot related. So I'm trying to make sure we get all the robot stuff out of the way first. David has something.
All right. I've got my my robotics team. They Iron Rain. They recorded this. Just made it a GIF, but they recorded this last weekend. This is the robot stress testing its outriggers, so its training wheels. The robot had a tendency to flip over all the time. So it looks like they can still tip it if they go fast enough in a circle with that rear wheel. But then the outrigger kicks in, and so that outrigger is just an omni wheel that's on a sort of rigid nylon hub connected to a carbon fiber rod, and the carbon fiber rod is attached via Ninja Flex to the robot frame, and it's entirely that mount, the Ninja Flex mount, the TPU mount, that is doing all of the flexing here. And it's proving to be very both flexible and robust. It's not showing any signs of wear yet. Those wheels are also the same TPU, and they seem to be working out all right. Those are the rebuilt wheels that I think I showed last time, where the motors are now mounted inside the hubs of the wheels, and the center of gravity of the whole robot is down quite a bit lower than it used to be. And so it is harder to tip, but they have found ways to tip it over. And there's probably a way that, if it hits certain elements on the field, that in that very tipped over configuration, which it should never actually see in competition, but if they accidentally get into that position, there probably still is a way to tip it over. But anyhow, that was just some progress that they were recording.
Stunt robots. Here.
Yeah.
So gold star for Iron Rain.
Do they get a star for that? I mean,
Well, I mean,
they're not here to show it. I'm just showing it for them.
it's got to be some kind of star. That's the most creative use of training wheels that I can remember.
Yeah, it's fun playing with that robot. That's for sure. It does some crazy things.
You got to enjoy what you're doing, right? Passion project.
Yeah.
So the motors in the hub, were they 3-phase brushless or something, or?
Nope, they're limited to these are standard hobby 550s. So a larger size motor, but you know, I think that they're all of the those are the largest motors they're allowed to have, right? So that sort of limits the power budget, and I guess makes it safer. There's fewer fingers lost and things like that because there's a power budget there. You know, the bigger FRC robots, those things with the pneumatics and all that kind of stuff, those are scary. Like, as a mentor, I don't want to be responsible for kids messing with those. Yeah,
So a
that's
550
right,
like
Ray.
this?
Yep, that's
Yeah.
what it
Oh,
is. Yep.
okay.
They have some there's a lot of gearbox options now. So there's
Yeah.
some really nice gearbox options. They pretty much all come standard with encoders on them as well, shaft encoders. You know, they're able to make a good bit of functionality around them. I've got the robot that I had back in the outdoor contest, the Robo Columbus. That one is actually using what do you call them? Wow, totally blanking now. But basically the higher power motors. What are they called? Like you have on drones and such. Totally blanking.
Cordless?
Yeah,
Outrunners?
not just cordless, huh?
The outrunners or brushless?
Yeah, it's brushless outrunners.
Brushless outrunners, yeah.
Yeah. And same size, same gearboxes, same pinions, but probably 3 times the power available. It's a substantial improvement, and much higher speeds too. But those are not allowed for competition, for the FTC competition yet.
So who sells a 550 motor with a gearhead and an encoder on it?
You can go to GoBuilda, you can go to Rev. We mostly use the Rev ones because they've got a really nice planetary gearbox system that has multiple stackable stages, so you can mix a 3-to-1, a 4-to-1, and a 5-to-1, and up to 3 stages. So you can get a lot of different ratios out of that. And basically, with that particular motor, that gearhead, you know, it can handle the full torque range, so it's not gonna break.
Yeah, I thought they had like a 20-to-1 or 40-to-1.
They originally had 20-to-1. They originally had 40-to-1s, and then they had a 20-to-1 planetary. But now they have something called the ultra planetary. You want to look that up. It's going to be a little bit more expensive.
I haven't been there in a while.
Because of the it's going to be a bit more expensive because it's so flexible, and you got to sort of get used to putting them together with just the right amount of torque on the screws. But once you get it figured out, it's been a remarkably cool system. And
yeah, I haven't
almost my teams have all converted to that one for the vast majority, and sometimes we use some others for specific purposes.
Yeah. Huh.
Very cool.
Generally pricier than what we typically talk about in this group, but they're not outrageous either.
Define pricey.
$100.
They're about $40, aren't they?
Wow, that's cheap.
If you're doing, I'm talking about the ones with the standard 550s.
Yeah.
So that's with the gearbox, with the encoder. That's the ultra planetary. It might be up to $45 now or something like that. But, and that's like with the standard 3, 4, 5 modules, and you can mix and match modules to get whatever you need. That's a much higher power one. So
This
that's
one is-
the max. That's not the ultra planetary. That's the max planetary. That's not the Neo 550. That's the full size Neo, I think. So
Okay.
that is a much higher, like the open shaft, the open receptacle on the front of that is actually a 1/2 inch.
Half-inch
hex.
tap. Okay, so let's.
That's
where's
much bigger than what you guys are used to doing.
My goodness, where are the ones you're talking about?
They're called search on ultra planetary. It's probably all one word. There it is, far left. So it's $40. And then those are the different stages that you can get that were to the side of it.
Yeah.
So they're the center thing that is like a 5 millimeter hex axle. But you can also bolt directly to the bolt pattern on the front of it, and that's usually how we do it.
Huh.
So
So are those 25
you get your encoder in
chains
there
brackets?
as well, huh? Typically,
Yeah,
yeah,
there's-
they have 25 chains. They also do 3 millimeter pitch HDT or GT3 belts. So they got a belt system. They got a number 25 chain system, and they've got both metal and plastic gears in 2 different modules.
And they got a corner turn module in here. Look at that.
Yeah, that's brand new this year. So we've bought one to experiment with. Haven't implemented
Bevel
it
gears.
yet.
Yeah.
Yeah. Otherwise, we normally go with Go Builda's bevel gear system.
Cool.
Yeah, I haven't looked at Rev in a while.
Yeah, we're pretty
So-
happy with those.
All right. Well, gold box for Iron Rain. Whether they can accept it or not is another issue, but in absentia, as they say, right?
In absentia. All right, I'll let them know.
I think David, did you say you had something to chat about?
Well, I actually was going to ask Chris, but it looks like he's vanished away. Chris, are you there?
I see
Yes.
his image there.
Yeah.
Yeah.
He just-
Sound is off.
Can you hear me?
Yes, I'd been drawn away to other activities, but I watched the video of a couple of weeks ago at your progress on the navigation and obstacle avoidance. And if you haven't made any progress since then, I had a couple of suggestions.
No, well, let's see. I don't remember if you were in that meeting. Maybe that's the one you.
I don't think I watched the video.
Yeah, where I demonstrated how far I got, and I kind of concluded and said, yeah, you know what, I'm pretty happy with it. It's not perfect, but I was reasonably happy about it. And then I kind of said, I'm gonna start spending some time on building up an occupancy grid, you know, making more use of my LiDAR data. So that's where I'm kind of at. I haven't really tried to tweak my avoidance and navigation any further because, you know, I really want to make more use of the LiDAR data. So
What I had noted when you were describing it, you said you had came to an epiphany that it had to do with using real sharp rotations when the target was a long way.
exactly, I didn't have enough really forward velocity commanding, and so it was kind of just, yeah, that was a really big part of the reason why I was doing one of these, because nobody was telling you to go forward.
Well, you may remember or may not in the talk I gave last summer about navigation, when I showed the little navigation algorithm, and I said I'm just using constants for the curve, for the turn, and that I had tried using the bearing to scale that turn, at least initially. I mean, that makes sense. So the further away, the steeper the angle is toward the target, the more sharply it would turn. And my observation was that I found that made the robot's behavior squirrely. The technical term is squirrely. And I think that's what you were seeing as well. And I would only go a step further to say that if you look back at that code, the navigation behavior itself always runs at full speed, or whatever full speed is set to. The only time it doesn't run at full speed is when you're inside the down ramp.
Can't talk about that.
The down ramp circle. Uh-oh, they're coming to get me.
Okay, we've been alerted.
All right.
Oh, Amber Alert,
Yeah.
Silver Alert.
Yeah, Amber Alert. That that the avoidance behavior can slow the robot down, and does. If it's either of the side looking, it slows it down to half speed. If it's the center looking one, it slows it down to 0. But the navigation itself always tries to run it in full speed.
Yeah, the reason I because the navigation was the first behavior I implemented before I added on avoidance. I just found that, especially because I'm in such a small space here, right? I found that if navigation was giving it too much forward velocity, it was making too wide of a turn, right? If I had to make a 90 degree or 180 degree, without sort of explicitly saying essentially, well, just turn in place until your heading is close to where it needs to be. It was making too wide of a turn, and I didn't have the room for it.
Well, okay, I would still argue that you want a fixed arc for that turn, and maybe you just needed a smaller fixed arc.
Yeah.
But at least what I found, when at least in navigation, using the bearing angle to scale the turn angle makes it squirrely. And I think that you were experiencing squirrely as well.
Good input.
That's all I had, Carl.
Thank you.
Well, I'd like to take the opportunity to thank David for taking the time to write down all those equations, because as I've been getting Mobot going, I've been implementing the slew equation and the where is it equation and all these other equations that are like the round it to plus or minus 2 pi, or can't limit it to plus or minus 2 pi. They're very helpful. And I think I'm wearing out the PDF because I've been scrolling up and down it so much. So thank you.
Well, Paul and I had a real interesting exchange about the specifics of odometry calculations, and I hadn't visited those thoughts in a long time, so I actually found it real useful. And I told him that it's good to keep you on your toes in the eventuality that you run into somebody that knows more math than you do, or than I do. So I appreciate it.
That wouldn't be me though.
Paul, I'd appreciate it if you could show me how to get a coffee ring on a digital PDF.
Challenge accepted.
Kareem.
That sounds like a final I had for controls, I think it was, or some circuit class where they had a control diagram or a circuit, and it was obliterated by a coffee stain in one part, and you had to figure out what was missing by the coffee stain. Yeah, that guy was a real riot. Cool. Okay. Anyone else have robot-y things?
Yeah, I got a question for you, and I'm not sure that there is a solution for this, but with my my Halloween skull here, one of the problems that I run into is whenever the servos get anywhere close to their limit, I get a high-pitched whine, and I keep backing off of the max, and I just can't seem to eliminate that whine no matter how much I back off. And here's, I don't know if I'm going to put my mic next to it so you can hear.
Yeah, I hear.
Is that coming through?
Yeah.
Now, my PWM update frequency on these cheap SG92R servos, right? You can get for, definitely less than $5 a piece. That might just be a limitation, but I've got the PWM frequency at 50 hertz, but I think that's what's recommended for those types of servos. Good. Is there anything I can do other than get more expensive servos to avoid that?
John, the sound, as best I can hear, sounds like that you're loading the servo. When you set up helicopters and things like that, you have to be real careful that the linkage is free all the way from one extent to the other. And that sounds a little bit like as you move to the far extent that something's binding or in some way it's loading the servo.
I must be tone deaf. I didn't hear anything.
And I think that, like I said, these are cheap servos, so it doesn't take much resistance to make them start buzzing. So I think
But that is the sound that RC servos make when you push back on, if you provide any resistance to their motion.
You might just look at the mechanical setup and be sure that, from one end to the other, that it's very free and it doesn't tend to bind.
Yeah, I figured that.
Grease the eyeballs, I think. No.
Say what?
Grease the eyeballs.
Grease the eyeballs. I think it's the linkages.
Well, that's a phrase you don't hear every day.
Hey, John, are you at the end of the travel of the servo?
Well, that's the thing is what I'll do is I'll configure it to where I'll set the maximum at just under the maximum travel that I can get, where it absolutely stops. And then when I get some buzzing, I'll back off from that. And then I'll back off a little bit more. And it seems like no matter how far I back off, when it gets close to to that end, it buzzes. So I keep restricting the range of motion, but I still get buzzed at the end of the range of whatever motion I configure.
Are all the servos the same? All the samples of the same model, giving a similar sound at similar places?
In this case, it's just one of them. The one that angles the eyeballs upwards is the one that buzzes. So maybe if I just need to play with that some more. But I've noticed even sometimes when I do this, I also get some buzzing too, even though the eyelids aren't completely closed.
And if you
Does it do it when it goes to the commanded range and it's not actually hooked up to anything?
Like mechanically, you mean, right?
Oh, you mean
mechanically not hooked up? Yeah. So there's no resistance to the motion.
See if there's something wrong with that servo, is what you're suggesting?
Yeah, it's more likely you're going to discover what David's been talking about, is that you're actually stressing the servo at the near the range where it's you're commanding it to go mechanically.
I'll just put some grease in there.
But yeah, just take it back out and you can do the same range of motion test and see if it still makes a sound when it's not linked to anything.
Yeah. Well, the parts on this design are so small that the tolerances definitely come into play, when you're 3D printing this stuff. So
well, I think these servos are rotary output rather than a linear output. That means that when they're swinging back and forth near 90 degrees, whatever they're hooked to is moved very powerful. When you get to the end of the swing, you're almost moving up and down there. So mechanically, you're at a real disadvantage at the end of the ranges because you're going around a circle.
Yeah.
But doesn't that depend on what his linkage is? Because it's kind of like at the top of a sine wave at that point. It's got the greatest mechanical advantage, right?
No, the least.
Well, one end of it depends on how you.
In the center, it would have.
Yeah, in the center, it would have the most.
Yeah. Yep. Has anybody
Well, the
experienced that to more expensive servos, maybe with metal gears, wind less or something?
More expensive is always better.
Always better. Huh? Oh, that's
Yeah,
big.
but I don't want to blow. These are really cheap servos. I don't want to blow a whole bunch of. There's 6 servos in there, so if I'm going to buy 6 Metal Gear servos and I still get the buzz, it's pretty much a failed attempt.
I've got $100 servos that do the same thing, right? They're really nice servos, much higher power, Metal Gear, and they will still make noise when you put big load on them.
John, I
Well,
think what everyone's really alluding to is the way these things behave when they're under load, because they try to turn, right? And if they're under there's some kind of flexing. There's always some kind of flexing in the mount of the servo or whatever it's connected to. So that will tend to push the gear back, wind it back the other way. Then it realizes it's no longer where it's supposed to be. So the engine kicks on again and kicks it back up. Then it gets the spring load, pushes it back down. And that's what you're hearing. That's what everyone's talking about, is this kind of resonance as it tries to drive back, then the motor stops because it achieves set point, then the springiness drives it back down again.
yeah, but the question I think that we're really asking here is, would a higher quality servo have less trouble meeting with that resistance? Because it's not
Generally,
depends on
yes,
the
it
rating
has
of the
more
servo.
power,
It's
but
not completely blocked. It's not like at the very end of its physical travel where it can't go anymore. It's just somewhere in that area where it's starting to get resistance.
and
Yeah, I
it's-
think,
you probably just have a low torque servo, and you just need a higher torque servo.
Yeah, I like Kareem's idea that
More
if you
money.
just disconnect if you disconnect the horn, does all the sound go away?
I have seen in a few instances where if I reduce the resistance, then the buzz goes away. Yeah. So yeah, there's no question that it's meeting increased resistance where it's starting to buzz, but it's not completely stopped.
Yeah.
I chalk
I
it up
would
to
say that
expected behavior.
the
Yeah.
expensive, very expensive digital servos that we use on the big helicopter are, I seem to have a delay here, are, because of the amount of forces that are acting on them, they're never in a position where, you command them to go to a certain position and there's no force on them when they get there. There's incredible forces on them when they get there. And one of the side benefits or side factors of this is that when they're sitting still with no load, they jump around a little bit. It's kind of obnoxious, actually. They're never quiet. Even with no load on it at all, they're not quiet. Of course, most of the time,
Hunting.
most of the time, when you're flying, they're under load, and so they don't do that. But when they're just sitting there on the workbench or on the, out in the field, they hunt around that 0 point. And they got so much torque, they're just so willing to try to do something.
So speaking of that no load thing, and sometimes the servo is not going to go there, I have a Radio Shack branded servo. I can't tell you where I got it from or what I did, but it's supposed to go from 0 to 180. And guess what? Can't quite make it to 0 and does that same thing you were talking about, John, where it sits there and buzzes when I tell it to go to 0. And if I back it off a few degrees, the buzzing goes away and it's okay. It just simply can't get there. And so maybe that's happening on your servo too. If you just take them out of the mount and just let them run free, does it still happen that way as well? If it does, you probably want to put a limit somewhere on in your software about how low you let that go. That's what I would do.
That's exactly what I've been doing. Is I keep reducing the range, but now I'm and I'm well less than 0 and 180. Well less than 0 and 180 on all these servos in any of the configuration.
Personally, I think you just chop that up to quality, but what do I know?
Yeah. One other thought, John, is you could, do you have any extra servos? Just exchange it out and see if you got. Otherwise, you want to really find out, is it the servo or is it the linkage? Those are the two, is there something about that linkage that's causing you an issue, or is it just the servo? So exchanging that buzzy servo with another servo, either fresh off your bench or taking the eyeball out of the other one or whatever, and exchanging positions. Do you still get it?
I think that right now I've reduced the range, the configured range of motion on several of the servos. I'd say half the servos will, prior to my tuning, about half the servos would buzz on me.
Okay.
So basically what I'm doing is I keep reducing the range, but it's starting to eat up my useful range of motion that I want.
Yeah.
John, I think behaviorally it's, I think it's okay because, it's like rolling your eyes up. It's like, disgust, annoyance. So if it makes a little annoying little humming noise, that kind of reinforces the motion of the eyeball going, to the right and, so it's probably okay,
John,
Yeah, and it's not real loud. So this is not a showstopper. I mean, if it performs like this on Halloween, I'm just fine.
okay, if it's not a showstopper, then just ignore it. But I would say that bye, Chris, it sounds like that your mechanism itself has a lot of friction in it, so that no matter what you set the endpoint at, the servo can't quite get it there. It gets real close to it, but it can't quite get it there, and that's when it ends up buzzing. And so when you back off in software where you're telling it to go to, it doesn't really change anything because it's still a high friction linkage. And in which case you could fix that with a servo that had more power.
Yeah.
I guess what I'm hypothesizing is that you're not actually getting to the set point because there's a little too much friction in the linkage, and that causes the servo to buzz.
Aren't there some servos that are made actually like muscles where you can with electrical stimulus have the material contract or relax?
I
Oh,
think those are
muscle
called,
wire?
muscle wires, yeah.
Yeah.
That and shape. I think there's some other things out there called SMA, shape memory alloys.
Yeah.
That depending on you heat them or heat them or let them cool, they'll return to their shape. And that
Well, this design I downloaded for all the linkages here. I can't show it, I guess, but the guy who posted this actually has an advanced version of this. Well, I say version of this is that his design is almost completely different. Much fewer, there are far fewer 3D printed parts and more like RC car linkages in there. So at some point I may decide, I want to see if I can build his advanced design, and I might actually, it might actually fit things better into the skull.
The helicopters and actually airplanes now use these ball links that are really nice. It's a little plastic thing that a steel ball on the end of a rod snaps into so that they can rotate in multiple directions. And therefore they don't tend to wind up. But John, if it's just the one servo making the eyes look up and down, maybe you just replace that one servo with a slightly stronger one and it'll go away.
You could also look at the current that servo's consuming, and if it's much more than the others, that's an indication that something's binding, or maybe it's just a bad servo.
All right. Well, I think that's about all we can do for that for now.
Yep.
Cool.
I want to know who has the watch.
I believe that's Doug.
60 minutes, I think.
I muted Doug once. I'm going to mute you again, Doug.
Go ahead.
Okay. Alrighty. Yeah, that was driving me batty earlier.
Doug.
Yeah, me too.
Like speaking from a dark place.
I
Golden
did
black
think-
house.
I did think that we were on 60 minutes.
Yeah.
Well, it's pretty easy to tell who the background noise is coming from. All I got to do is look in the upper right corner of their screen,
Yeah.
and
the
if that
little-
thing is blinking, they're the
Yeah.
ones that have the interference.
So it's you, John.
Well, at the moment, yes.
I thought it was you. I don't know.
Well, somebody muted me earlier in this session, and I think it's because either my cat was meowing or they could hear my 3D printer going, which is finished now.
Ah, that's
Definitely hearing the 3D printer.
Oh, was that it? I didn't think.
Yeah,
y'all
it
could
was
do that.
like cycling like every minute or so. It's like
Oh.
it was doing some rapid move.
Well, I was fixing the overbite on my skull, putting a new mandible on it. I resized things and he had kind of an overbite, so I needed to fix that.
a little bit of buck teeth there or something.
Yeah.
Harold, does the phrase running light without overbite mean anything to you? Dr.
Yeah.
Dobbs?
Boy, that's going back. That name means something, but I haven't heard that phrase.
Dr. Dobbs,
I know Dr. Dobbs really well, but I don't know that phrase.
Yeah, Dr. Dobbs' Journal of Computer Calisthenics, it was called. And underneath that it said, running light without overbite, with bite spelled B-Y-T-E. It was for those of us who were into this new thing called microprocessors. Ooh, the 8008. Ooh.
Yeah, well, I got speaking about that. Before I got to Dr. Dobbs, I was a big fan of. I guess his name is Steve Sierra, the circuit seller guy.
Ciarcia.
CRC, yeah. And I picked him up all the time.
So I got a question. Do you guys, or are people here interested in object-oriented design?
I've done it for years.
But,
Yeah.
Okay, well, it sounds like there's some interest, because I came across an interesting thing, because I haven't done much with inheritance. Professionally, I sort of never really ran into what I thought was a need for it, but in this Mobot project, I found a really good use for it. But separate from that, I was digging into the Arduino code for how they do their hardware serial and print. So Arduino has serial.print, serial.println, serial.write, serial.read, serial.available. And I was digging into how those classes are organized. And I found it very interesting. And so I drew a class diagram. And if you guys are interested, I'll share it and just say a little bit about like how it's organized and I think why they did that.
Yeah. Why not?
The thing about object-oriented programming, I was a software engineer for 34 years. And the thing I've found about object-oriented programming is that if you spent several years programming procedurally, and then you're introduced to object-oriented programming, it just seems like no matter how many years you spend doing OO, you still start out thinking procedurally because it's really, really hard to give up. So a lot of my projects, what I'll do is I'll kind of force myself to rewrite them. I'll start them out as sort of a sample program. And then as I build them, I'll go, well, I can make a class out of that. And then I'll refactor my code to make it object-oriented. But I never start out, at least on a simple project, I almost never start out with designing classes first.
I've gotten past that, John. I've gotten to where I think about what are the things, the countable things in the system, and they should be classes like messages. Messages should look after themselves, and so you can't use it by itself. You have to subclass it, and something that realizes it has to implement this void write char. So that was kind of interesting. And then the stream class subclass is print. So a stream, if you've done C++ or even in Arduino, you can say C out less than a stream, I think. But a stream is a flow of characters. So it can flow characters to so by subclassing print, it inherits all of the methods of print. So stream, if you define a stream, if you instantiate a stream as a subclass of a print, it gets write string and print float and print double and print int and all that jazz. But it has to implement the write char. But a stream also is something that you should be able to read streams of data from. So it defines some methods available to check how many bytes are available for reading, read to actually read some number of bytes, and peek to look at what some number of bytes are, or maybe it's the first byte, I don't remember. But whatever thing implements or realizes that has to implement that method. So this is kind of interesting because they're sort of building up these concepts from a basic thing that knows how to print to a stream that knows how to flow data streams in and out of it using prints to print doubles as ASCII characters, etc. And then the highest level of the hierarchy is the hardware serial. And the serial object, where you do serial.println, is an instance of hardware serial. It's hardware serial 0. But you can also implement hardware serial 1, hardware serial 2, etc., and give them their own names as instances of that. And the hardware serial thing, class, is the thing that actually implements write char. So when you do like a print line with a double, that ultimately ends up being a write of some number of chars that ends up calling the hardware serial write char that then sticks those bytes into the FIFO. So I was like, wow, that's really interesting. Anyway, that's, I think that's as much. It also implements available because it has hardware serial owns the serial port, so it can, and it owns the buffers, so it owns the interrupt service routine that reads data out of the UART and puts it in a FIFO, so it's instantly available for anyone that's trying to read it. It also owns the write buffer, so that anyone who sticks something out to go out to so they do a print string. So that can flow all the way down to the print, and print string does a whole bunch of write chars, and the hardware serial implements write char that puts it in the buffer and handles the unloading of the buffer into the UART. So I was like, wow, that is really sophisticated object-oriented programming. And I just thought it was just really clever.
Well, I was writing a set of routines in Python, MicroPython for LCD display. And I said, okay, I want to use the same underlying thing for a write directly to nibble 4 pins. And that is the same as what you would do to a I2C backpack. And so what I did was I wrote a base class that looks to the children to supply the actual interface to either the nibble interface or to the I2C. And magically, the children then provide all of the base capabilities.
Yeah, yeah. It sort of turns it back on itself, doesn't it? It's kind of funky.
Yeah. Yes, it's useful. It's very useful.
Yeah, yeah. Like the higher level classes provide higher level functionality, but by being required to implement the virtual functions, they actually also supply the very bottom level of functionality.
Well,
like,
in my case, what I did was that the children were children of the base class. And because they were children of the base class, they automatically inherited the capabilities without my having to put those capabilities into the children.
Yeah, that's right. And that's kind of one of the slick things about inheritance. And what I did with this Arduino log, because it said it would work with any kind of stream object, I made my own what I called a log stream object that extended print, and I just made the available and read and peek null methods, because there's nothing in a logger that needs to read or peek, and just implemented the right char to provide something for print. And this logger just talked to my log stream, which used print. And so all of the things like printing a double, or printing a int, or whatever, just sort of magically worked. It was amazing.
That all just seems so needlessly difficult. If you're working in C and you have libc available, then you have printf and all those functions that allow you to talk to any kind of data type with just one print command and a format string. And down at the lowest level in the library, it calls a weakly typed function called IO character. And IO character then is responsible for moving the character normally into standard out or standard error. So Dave, all I did was I repointed standard error to my LCD, and poof, any printf statement that says talk to the standard error shows up on the LCD. You don't have to write anything. I've always thought that the way they do it that Paul was describing here seems real awkward, because you have to have a different print statement for each kind of data that you want to print. Whereas, as I say, if you're using a C compiler, you already have all that.
And it's a philosophical difference, isn't it, David? Because C is a weakly typed language and C++ is a strongly typed language. And there are philosophical beliefs that one is better than the other. And
I'm not arguing that in particular. I'm just saying that this seems like a really complicated, long way around doing something that's actually already, if you're writing in C, and C++ is C with just some extensions on top of it. Then if you're using libc or libc++, you already have the function where you go in and you change one process, this IO character, and tell it that when it gets a standard error as its file descriptor, it should write to the LCD instead of to a serial port or wherever the next process in line it's being piped to. And that just seems so much simpler than this much more complicated way of achieving not quite as flexible an end result.
Yeah, basically you're using the C library for the formatting.
Yeah, because it already has all that stuff.
Yeah, right.
clearly both can work and both do work, but
one's a whole lot clumsier.
I think that would be a judgment call that may not be generally applicable, may not be broadly applicable if one is actually comfortable with classes. As an example, the subclassing can be very helpful when handling messages, because there are certain fundamental things that each message should have, like a checksum, a CRC, a length, a sequence number, and those can all be put into a superclass or a base class, and you can then only put the logic needed for each particular kind of message into the subclass, so it can save you multiple functions, a lot of boilerplate code. And it's not to say that you can't work around that in some way without using OO. You can create functions to do the boilerplate, but it's kind of a different approach.
Well, absolutely. Do you really think that it's easier and a better idea to have a separate print function if you want to print an integer than if you want to print a string? Why should those be separate functions? They're going to do the same thing.
This is the kind of example where OO works well. But what I was kind of alluding to before is it's somewhat difficult to create a project from scratch, because when you design your classes, you have to have a clear picture of what to abstract, and what should be abstract and what should be concrete. So you kind of have to evolve it as you go, and you will make mistakes. Sometimes you'll abstract too much away, or sometimes there will be sometimes it'll be too much, sometimes it's too little. So,
but don't you think that's just habits of a lifetime? I speak a little bit of French and a little bit of German, but I always start off in English and then translate. But
I don't think so, because the
I
problem
think
is
good speakers don't do that.
when you start any project, there are always unknowns. All right, you don't know everything about your project when you start out.
So you're saying you can only learn those things procedurally and then translate them into.
No, I didn't say that.
object-oriented problems?
I'm saying that it can be difficult to create a new project from scratch because you don't have perfect knowledge about your project to begin with. It doesn't mean it just means you'll have to refactor your classes as you go. But it's not a magic bullet.
I think what we're broaching on some of this here is there's a concept, and I think this is what John was kind of alluding to on this thing, is you start with a minimalist and you kind of discover what you need, as opposed to sitting down and trying to think of all the things you need, because that's never going to happen. And I come to the concept there of something called YAGNI. You're not going to need it. That's what it stands for. And by building up and adding things as you go and doing it in such a way that the object-oriented side of the house affords, it allows you not to have to go redo a whole bunch of things and build up on the base as you go, and add things as you need them, as opposed to what you think you're going to need that sometimes you never use. Because I know all of us, if you've done very much coding at all, you're going like, I'm going to need one of these, and one of these, and one of these, one of these, one of these. And as you get going and doing, and you've done all your code to handle all those things, and you realize that 4 out of the 5 things you really didn't need, you really needed that. And now you've got to go strip all that code out and do some extra things with it. And the object-oriented world kind of allows you to just allows it to make that an easier deal. It's not any better. It's not any worse. Yeah. It's just a maintenance thing. A lot of it for me comes to maintenance.
Yeah. And you always see claims that, well, it's object-oriented programming is more natural. It's more natural to think that way. And I would say that that's really kind of not entirely true, because when you think of when you create a project, your project is in terms of something you want to do, not something that is, right? You always think of what you want the actions, what you want the code to do. So you have to make that difficult up front to translate from what you want to do to what is, and that's not entirely natural.
I would disagree with you there, John. And as a concrete example of that, consider the code that should live in the ESP32 part of Mobot. So there should be a interface to the serial port. There should be a motor's speed control, and there should be odometry. There's 3 things. So, and they're not procedural. They're things. Sure, they have behaviors, but they really are identifiable things that you can say, these are just natural objects.
But you're looking at a design after the fact.
No.
Try to create something completely new from scratch. All right. And it's a little bit
new
more
for me.
Yeah, I guess I think, but okay, now you're saying you could make each one of those as separate objects. To me, that approach assumes that there is no latency between, and any computations that have to be done in these blocks, there is no delay. It's like instantaneous, or that they're all running at the same time, right?
No,
that's-
no, it doesn't assume that at all. In fact, the looking at the timing between objects is no different than if you wrote functions that did these things, and the functions were sequenced, for example, in some kind of while one loop. The timing is a whole different aspect that you need to also consider. And I've chosen to make a task that runs odometry, a task that runs motor speed control, a task that runs the comms link, but it could have been done other ways, like in a while loop, polling them. But no, I
like
think
most of the robot projects.
I think the timing aspect is unrelated to the objectification, which is a structural aspect.
I'm not trying to shoot down object-oriented programming. I'm just saying you have to acknowledge the difficulties. It's more difficult, I believe, to do object-oriented programming than procedural programming because of the way you tend to think of you have something, you have an actions that you want to accomplish, and you have to translate those into objects.
Yep.
John, I would just say that I used to be a procedural programmer, and I completely understand where you're coming from. And I saw enough people making objects that I came to and took classes, on how to do that stuff, that I came to embrace a worldview that looks for what the countable things in a system are, and says maybe those should be instances of classes.
I understand what you're saying. I mean,
yeah, maybe I never got into it enough, but how do you work out those things? Because they're, as far as who runs when, and how things are coordinated. How do you deal with the timing aspects of those things?
But those are not really questions that are unique to object programming, right? I've done a lot of object programming back in my misspent youth, and it seems that the complaint that you don't really know where you're going when you get started is universally applicable to all programming environments, and not just procedural or object oriented. And also the problem of how things should be compartmentalized. Does this function belong here, or does it belong over there? And those are not necessarily intuitive things that when you get started, unless you've done it before, done that particular problem before. The object stuff we did, which was at a speech recognition company I worked at, was fun. It was a fun way to think about problem solving. And I'm not opposed to it. And so much of the world is written that way. It's good to be comfortable and to be able to understand what it's doing. For my own uses, though, I use a highly rarefied, very powerful form of assembly language called C.
Yeah, I don't know. I guess I tend to think of, okay, what I want this robot to do, kind of like, I think what David would say, what's the mission? It's like, okay, it starts out and it reads sensors, and then, or maybe it has a navigation goal or something. So how's it going to do those things? And it can always be broken down into like functional blocks, like like PID loop. You want to have a PID loop running all the time, and so there's like a system tick that comes through, and all those things have to line up or be present so that you can eventually determine what you want your motors to do.
Oh, none, and then we'll dump it.
So to me,
Sorry.
it's like a procedural kind of thing. And so that to look at it like with a class structure, it always felt like I don't know, it was much more difficult to think about.
But
I have to
you
say
can,
the way I've written code, and basically since I started doing it in the last millennia, is that I tend to write little short pieces of code that do singular things.
Yeah.
Very rarely take more than one page. And then I build upward and then test the shit out of them, and then build outward and upward from there.
Mhm.
And so I'm not sure I run into the same problems. I was going to laugh because I say they're rarely longer than one page, but I think Carl believes that's because I don't put in any comments.
Yeah, and you use variable names that have at most 2 characters.
Well, okay, X and Y and A and J, I and J and A and B and C, those are all well understood from math.
I'm just saying.
If you have a pointer to a task, that pointer might be a T. That reminds you that it doesn't really need to say pointer to a task, or better yet, my pointer to a task.
And since everything can be separated by semicolons, you're not worried about space. You can just make that one really long line, so you only really need about a half a page to do whatever.
That's right. Spaces don't mean anything. Yeah.
I'm not arguing the style. I think the style is really well suited to the world where you enter your code with switch at a time.
oh,
Fat
Tone it down, tone it down.
fat fingered.
brutal.
That switches.
But Ray, to address the point you made about you think, well, it needs to move from here to there, and so it needs to do this, and it needs to spin some wheels, and you work your way downwards and sort of refine it from a functional perspective. And certainly that works, and I'm not saying it doesn't.
Yep.
But I'm just pointing out there's another way you can think about it, which is to think that there has to be something that tells it what to do. And so let's just call it a thing that tells things what to do. And then there has to be something that receives commands and acts on motives. So that's another thing. And so you're not dealing with it has to do this, it has to do that. You're more thinking about it from there has to be this kind of a thing and that kind of a thing, and they should interact in this kind of way. And then you can figure out the interfaces and sort of drill down by injecting procedures into the things that you've identified. It's sort of the inverse, because the way that you've proposed, and I'm not saying the way you proposed is wrong.
Yes, he is. Yes, he is.
No, I'm not. I've done procedural programming for, but you will ultimately end up extracting structure out of your collection of functions, right? You'll end up with a bunch of methods that have to do with the low-level control of PWM, and so you'll put them into some C file, and then you'll end up with a bunch of other methods that have to do with navigation. You put them into C file, and effectively you're extracting structure after you've made the procedures. And so I think that's really sort of the difference is, do you build the structure first and then populate it with the methods, or do you build the methods first and then as you're doing it kind of extract the structure?
Paul, you remember the talk you gave, and also Rudd gave a good presentation on the behavior trees a few months ago. And since then, there was a good presentation given at the Seattle the Homebrew Robotics group. And I've gone back and read some of them. And this bears on this only tangentially. But what I noticed was when I first started writing robot code, which was like in the 80s and 90s, I just wrote big behavioral structures. And they tend to get bigger and bigger and harder to control. And about that time, I discovered subsumption, which was a way to formalize that. And so basically, that's what I've done ever since. So when we looked at what basically the gamers were doing at the same time that I was building those first robots, they had confronted the same problem. They were doing this procedurally, and they ended up with these enormous structures if then else, if else, if then else, that nobody really knows what they're doing and they can't control. But instead of giving up and going to something else, they develop behavior trees, which, as best I can tell, is a way to formalize those and keep control of those enormous procedural trees. I'm not convinced, because it seems like that it's going the wrong direction to me. I can't imagine that a honeybee does it that way. Nonetheless, they actually solve the problem in a kind of an elegant fashion, but the problem is that those things become huge and unwieldy. And sometimes the argument is made that object-oriented code helps prevent you from falling down that particular rabbit hole.
Oh, we gotta get the parameters.
I mean, we've all run into that, right? You get a big, complicated robot system working, and you go in and you make change to function B, and now all of a sudden, a whole bunch of functions that you didn't touch are all behaving differently now. And so, how do you isolate that? And that's one of the things subsumption does for you, allow you to run those independently with each other without them screwing up other functions. But
Yeah.
That's the classic problem, and these things can get enormous. And I'm sure some of you guys work in your professional lives on systems like this that are millions of lines of code, and nobody knows the whole thing.
Yeah, and the concept of subsumption, I think, is not too far away from an object-oriented design, because each of your behaviors is an isolated, countable thing. There's only one of them, but usually, but it's a thing. Very
And
much.
it has a set of
Countable
characteristics, and it's encapsulated in what it can do and how it behaves.
Yeah, it's a concept. It expresses a concept, and it's isolated and contained, and it has some interfaces. That's an object.
Well, if you go around on the net and look at published computer code for robots, I would say more than half of it is object code.
Object-oriented, yeah.
Oh, by the way, David, I'd like to tell you about your block diagram. Where you had all the velocities and rotations coming down from the behaviors through the arbiter, and then out the bottom of the arbiter you had bot vel and bot rot, which were the last commanded velocity and rotation from whatever behavior was last running, and then that was the input to the slew on the for whichever behavior ran next. Well, I implement that in ROS by whatever. No, I don't have subsumption, but because I just got those simple behaviors. But whatever velocity and rotation command goes down into the ESP32, there's a message that comes back out of the ESP32 back into ROS that is the last commanded velocity and speed, and then that's input to the slew of whatever module is running, controlling the robot at that time.
So you're just publishing the ESP32 is just publishing whatever its last command.
Yeah. So thank you for that concept. It works great.
Oh, I see that. I'm sorry.
That's no worries.
Carl, you going to show us some pictures of old cars?
All right. Well, yeah. I mean, I didn't want to interrupt a good robot to talk because this is a robot hub thing. But if you guys want to see it,
show pictures of old cars.
I can show you why I haven't been spending too much time on robot things lately. If you're interested, kind of a fun story. I'm going to pause the recording for the moment. Just the pause button.
Yeah, right.